Hello everybody, this is Math 140, day 5, and now the topic which is arguably the hardest in the entire module, I think, and that's multivariate quadratics. It goes to multiple variables, and we want to divide and multiply them, and in order to successfully do that and simplify, we need to look at factoring them. This is going to be just one big example. And let me start with the problem. Simplify x squared minus xy minus 12y squared. We have two variables, a quadratic polynomial in two variables, and that's divided by 2x plus y, and we're supposed to divide this by 2x plus 6y divided by x plus y. Told you, it was the hardest topic in the module. Okay, so the first thing is, when we divide two fractions, it's the same laws that apply for fractions of integers. We multiply by the reciprocal. Let's just write that down. So times x plus y divided by 2x plus 6y. And now we could just multiply that out and we would have an answer, and we could expand it, and it would be counted as wrong because it's not simplified. How to simplify anything here? The answer is factor as much as possible. 2x plus y can't do anything about that, so this one is good. X plus y can't do anything about that. 2x plus 6y, that obviously has a factor 2 that we can pull out. Two times x plus 3y. And now the big one, the quadratic. We don't have a real technique for doing that, and the explanation that Alex gives actually is non-existent. It just says factor it, and that's the answer. So I'm just gonna say, for this example, the only thing that matters is, can we simplify it or not? And that means, is there maybe a factor 2x plus y hiding in there? Or is there maybe a factor 2 hiding in there? Or a factor x plus 3y? Any of those three would allow us to simplify, okay? Because that's the factors that we can see in the denominator. And okay, there's no factor 2 in this polynomial that we can pull out without getting fractions, and we don't want that. That's not simplifying. So 2 is out. Factor 2x plus y, also out, just because of the leading coefficient 2 in front of the x here. We want to stay in the realm of integers, polynomials with integer coefficients, and the leading coefficients of two polynomials multiply whenever you multiply the polynomials. You get the leading coefficient of the product. So you could never get a leading coefficient 1 in the product if your factor has a leading coefficient 2. So that is the reason Why 2x plus y cannot possibly be a factor of x squared minus xy minus 12y squared. It leaves me with the x plus 3y. And you might guess Psychology 101 tells you that's going to be a factor. Okay, so to really check that out, I put a question mark over that equal sign, but we write x plus 3y, and then we just go from there and try to fill in the rest. Go from there, fill in the rest. So that's much easier than actually factoring when you need to find both factors. Here we just need to find one possible factor. Can we fill in that question mark with the polynomial? So how do we do that? X plus 3y. One thing, it's going to be a polynomial of degree 1, a linear polynomial. So there's going to be no squares in there. But there could be an x in there. In fact, just plain x. That would work nicely when you expand it out, you FOIL it out, to get this x square, okay? So x will have to have the coefficient 1. And to get the 12y square, I actually copied it wrong, I'm sorry. That was supposed to be a negative here. So to get the negative 12y square, we want to see minus 4y. In this spot, when we FOIL it out, you can tell we're going to get negative 12y square. And then we need to check the two mixed terms, 3yx minus x times negative 4y, gives me a total of negative xy. It actually works. It pans out. Hooray! That means there's an actual simplification going on. I can cancel out the x plus 3y, and what's left? That's going to be the x minus 4y and the 2x plus y. And the x plus y. And the lonely factor 2. Then we can FOIL this out. This is x squared minus 4yx plus yx, so minus 3xy total. Minus 4y squared divided by 2 times 2x plus y. Done.